Alex,
Hi.
how are you?
Good. How about you?
Good. Were you here yesterday?
Yeah.
Oh, okay. That's fine. I mean, I don't see everybody's list and I go, I don't know if I saw Alex yesterday. It's kind of just curious.
Hello.
Hello, Adam. Hello, Mr. Krebs.
Morning.
Morning. Madeline, good morning. Sophia, good morning. Caitlin, good morning. People are just popping up all over the place here. Oh, Adam, because of you, I did something. Okay? You got my joke yesterday. I saw you smile.
I smile at a lot of your jokes.
Okay, let's see if I can find what I did this morning. Oh, I hate it when I actually got to find something here. You know what? I have way too many apps. That's my issue. Oh, here it is, right here. Okay, so I came up with an app. I'll share it with you. I got to do a few things because this is complicated. You know, it never can be easy. Well, I got to let people in here. Because I don't really have a life, and all you guys are the only people I really think about. And people are hopping in here, and I haven't been able to do this. Okay, let's see if I can successfully share this. Do you see my phone here?
Yep.
Okay. Do you see what it says right here?
Yes.
There's a countdown app. We have 6 days, 2 hours, 12 minutes, and 48 seconds. I think that's colossal. I was just up here with participants. So anyway, yeah, if I needed any more or less sleep, I can get up and look at my app. Okay. Kind of sad, isn't it? Alrighty. Do you guys have any questions? I do have something because I started looking at your last free response questions, and I want to talk about a couple of things that I think are important. No? Okay. Here's a question before I get too far. Did everybody have the opportunity to see the demo? Okay, I haven't even looked at it yet because it's just like I've got a whole bunch of stuff to do that I'm prioritizing, and I didn't feel that was a priority. And so by the people that I don't see, because I don't see the majority of you, somebody would say something if they hadn't seen it, correct? I would hope. Okay. All right, so let me get this countdown because you guys don't need that. That's me playing on your stress. So it's me being 13 again. So I apologize for that. Okay. But if you're an older sibling, you're used to that. If you're a younger sibling, start getting used to it. Okay. All right. So I got this problem right here. For some of you, that may seem familiar, except the letters are different and the numbers are different, correct? And so I want to point out a few things. So this, they call it a differential. It's a derivative. It computes slope, correct? That's its purpose in life, nothing else. And this is the dependent variable, and this is the independent variable. In other words, this is the input, this is the output, correct? Like dy dx, dy is the output, x is the input, y is dependent on whatever you put into x, correct? So what I'm saying is, I got some more people coming here. So I gotta multitask, which I don't know if I can do here. All right. Let me go back. So this, K, whatever K is dependent on whatever T is. So if I have, like my truck is dependent upon the gas that I put in the tank, correct? If I put the wrong gas in, it may not run correctly, correct? Because it's dependent on that. Would you agree with that? So if I put diesel into my truck, I got major problems. If I put sugar into my truck, I even got a worse problem. Don't ever do that. That's not a good choice, okay? So what they give you here is this is your variable that creates your slope of your tangent line. Right? Because the first thing I asked for tangent line, and you know the point is 1, 2. And this is T, and this is K. This is X, this is Y. All right, are we okay with that? It doesn't ask you for T here. It says to compute the slope, I'm going to throw not a curveball, something worse than a curveball, a knuckleball that just drops right in front of you, and you're not expecting it. You're a fast pitch hitter. And then you've just learned that the ball coming at you can make turns, and now they throw you this thing that just falls straight down. And so what am I going to put in here? Not 2, but 1. If I did put 2 in here, I would get the wrong slope because it doesn't ask for T, it asks for K. So to come up with the slope of the tangent line, here's A equals, and I know it's going to be T minus because that's my independent variable. And it's going to be T minus 2 plus 1. And now I got to put the slope in, but I'm not going to put 2 in here. I'm going to put 1. And 3 times 1 is 3, plus 1 is 4. The square root of 4 is 2, I believe, and 3 times 2 is 6. So there's my tangent line. And the reason I bring this up is this is on the second page of that. That was the second question, correct? And a lot of you didn't put G into there. You put T into there. But it doesn't ask for T, it asks for G. So then it asks you to approximate.
Mr. Kruger,
Yes.
how'd you get the T minus 2?
Oh, I screwed this up by, I should have had 2, 1 here.
Got it. Thank you.
That was my mistake up there. That's a teaching mistake. Sorry. Yeah, because your input value is your independent variable. K is dependent on T. That's what this means right here, like dy over dx. Is that better, Landry? Okay, so yeah, that's my mistake there. So now I'm going to do B. I'm going to approximate. So K of 1.1 is approximately 6 times, if I have 1.1 here, it's going to be a negative 0.9 because 1.1 minus 2 is a negative 0.9 plus 1. And that gives me, I believe this is a negative 5.4. I believe I get a negative 4.4. And so it's approximately that using my tangent line. I know it's not that because this is, I'm using a line, I'm not using the actual function. Are we okay with that? The next thing it does, they threw a lot of knuckleballs on this one, but I think this is a good problem to talk about because I think this is something you're going to see. I belong to a calc teachers group and they're throwing this out on a lot of their practice exams. So the next one it asks, using separation of variables, find k. So once you find the function k at this particular solution. So it wants you to find k of t. So I'm going to have k equal something. I got to get k by itself. So the first thing I'm going to do, and a lot of you did this correctly, you wrote 1 over 1 plus 3k to the 1/2 power dk equals 3 dt. And I only looked at a few people's. I just was kind of curious to see, because I wanted to have a discussion, right? I want to have a discussion that's helpful. So it's not natural log because this is not a 1. Does everybody agree with that? So you've already got a point if you get to here. And so I'm going to write this as 1 plus 3k to the negative 1/2 power dk equals 3 dt, and I'm going to integrate both sides. And I'm going to do this one first. I'm going to have 3t plus c. Now I'm up to 2 points. Now, how do I integrate this? Well, I think we talked about this yesterday. And I think Landry's the one that brought it up. He says, oh, yeah, I know how to do this. And there was one little curveball to it. Remember, Landry?
Yeah, you got times by 1/3 on this one.
Right. And why is that? Because in here, since this is a derivative, the derivative of 3k has to be in there too, doesn't it? So what I do is I multiply by 3, but y isn't in there. It's because there's a 1/3 there. So I'm going to have 1/3. I'm third. And then I'm going to have parentheses 1 plus 3k. I'm going to add 1 to this. I'm going to get a 1/2. And then I'm going to multiply by the reciprocal, which is 2. Are we all right with that? And some of you do substitution, and that works fine and dandy too, because I've seen people do substitution and do it very successfully in solving this integral. So I have 2/3, and I'm going to write the square root here just to make me feel better, equals 3t plus c. So it doesn't matter when I solve c here. So again, t is 2. So I have 3 times 2 plus c, and k is 1. So I have 2/3 times the square root of 4, because I'm going to get 3 times 1, 4. This is going to give me 4/3 is equal to 6 plus c. Oh, yuck. So I believe I'll get a negative 14/3 is equal to c. I believe this is 18/3. 4 minus 18 is a negative 14. So now what I have is I have 2/3 square root of 1 plus 3k is equal to 3t minus 14 thirds. And so now I got to get k by itself. So I'm going to multiply both sides by 3 halves. So that's going to give me the square root of 1 plus 3k is equal to 9 halves t. And if I multiply this by 3 halves, I believe I get minus 7. Am I going too fast? Okay. So now I'm going to square both sides, and I never multiply that out. I just will write 1 plus 3k is equal to the quantity 9 halves t minus 7 squared. And I'm going to get k is equal to 9 halves t minus 7. This is one I made up because you can tell, so it's because it's so god awful. Minus 1 divided by 3. And now I'm going to plug 1.1 into here. And so this is where I'm going to use my calculator. They will not give you this much work, I don't believe. So I'm going to take 9 halves, 4.5 times 1.1 minus 7. I'm going to square that. I'm going to subtract 1. And I'm going to divide by 3. And when I do that, k of 1.1 is approximately 1.068. I get this. So the things I wanted to bring up. First of all, I feel that one of the questions is going to be this idea of separation of variables. And this is always 5 to 6 points. The second thing I want to bring up is when they give you the derivative, that's not in terms of the input value or in terms of x or in terms of t, but in terms of the output value or the dependent variable. Make sure you take a little bit of time and say, all right, what am I supposed to put in here to get the slope? Because all of a sudden everything built on the correct slope. Does everyone see that? So even though you may have done this wrong, understanding what I think I would give you credit here. So again, I just looked at them, I started to correct them, and then I realized I had goofed up when I corrected. And I got to restart because I had made the values I made each problem was incorrect because I had forgot there was a second page. Okay. Was that helpful? Okay. Then I wanted to talk about one more problem and how to, I got a really good question yesterday of how do you do limits? And to be honest with you, I think I can use the back side of here. I love L'Hopital's rule because it makes it a lot easier, I think. And so I am going to look at this particular one. And I'll give you some examples of when I wouldn't use L'Hopital's rule. But I think they might give you one on that. So let's say I have this. I'll give you this one. Okay. And then I'll talk about a couple that I think it would be easier not to use L'Hopital's rule, but let's say if you do that limit. And I have no algebraic way to do that at all. So what I do immediately is I write this down. The limit as x approaches 2 of the sine of x, the sine of 2x, and that gives me the sine of 4x. Excuse me, the sine of, I should have this, make this pi, sorry. So that gives me the sine of 2 pi. And the sine of 2 pi is 0. So I'm hoping this is 0 also. So I take the limit as x approaches 2, the natural log of x minus 1. And substitution is the easiest way. So I try to substitute right away. And I'm going to get the natural log of 1, which is 0. So because I get 0 over 0, or if I got infinity over infinity, or negative infinity or positive infinity, or positive infinity over negative infinity, I can apply L'Hopital's rule. What does that mean? I need to be able to take this derivative. And the derivative of this is going to be the cosine of pi x. And the chain rule says I got to come in here and take the derivative of this thing, and that's pi. Divided by the derivative of this thing. And what does that give me? Well, it gives me a fraction. X minus 1 is in the denominator, and the derivative of this, which is 1, is in the numerator.
Mr. Kruger,
Yes.
Josh said he just accidentally got kicked out and he wants to be let back in.
Okay. Yeah, and I could see that too. That popped up on my screen, but I was doing math. Sorry, Josh. Are you guys having issues with internet at home? Okay, if that's a concern, what I want you to do is if you want secure internet and you want to take this at school, contact Mr. Noner, okay? Because I'll tell him and he'll tell me to tell you to contact him. So I'm telling you right now, contact him if that's what you'd like to do, okay? All right, so now, are we okay with this so far? Okay, so now I'm going to take the limit of this as x approaches 2, and again, I'm going to substitute. And I'm going to have pi times the cosine of 2 pi, and over here, I'm going to have 1 over 2 minus 1. And I could have done that in my head, I guess. And this is going to be 1, and the cosine of 2 pi is 1, and so I get pi as my answer. I think that's the type of question they're going to ask you to take a limit on. The only time I don't do L'Hopital's rule is if I have something like this and I have square roots. I don't know if that's what I wanted. But you know, when you have something like this and you're going to multiply by the conjugate, something like that, I don't know if this is an appropriate one that I want. But square roots, taking the derivative is a little bit more complicated. Does everybody follow that? What I mean by that? So, and I'm kind of stuck in my brain of a problem I want to give, but I almost always look to use L'Hopital's rule. Even something like this, if I have the limit as x goes to 0 of the sine of x over x, and I can see that I'm going to have 0 over 0, I'll do L'Hopital's rule. And if they don't ask you to justify, but since it's free response, I think it's to your advantage to say, take the limit of the sine separately from the limit of x and write them as 2 separate limits. Don't do this. I got yelled at and they made me cry at a conference. Because they'll say they shouldn't be allowed to write 0 over 0. All right, I understand that. But I mean, you're dealing with students that are dealing with time. Oh, we want them to write it separately. Okay. I'll have them write it separately. Are we okay with that? All right. What are we doing on time? Let's see. I did have another question. Is tomorrow Thursday? It is, isn't it? Okay. Let's see if I have it here. Yeah, it's this one. This one I would use, I would use a calculator for, because I'm looking, that's a pretty complicated equation, but they could give you an equation like this in which they're having movement. They're having movement along an axis. And so they give you a velocity, and then they tell you position. Have I done this one before? I know I've done one like it, but I don't think I've done this problem. Is that correct? Now let's slide this up. And so the first question is, at time t equals 4, is the particle speeding up or slowing down? So what do you have to look at to decide whether something's speeding up or slowing down?
Acceleration.
That is one of the things you have to take a look at. I agree. Okay. You have to look at one more thing.
Velocity.
Velocity. So you need to look at both of those. If the sign of those, both of those, are the same, you're speeding up. If your acceleration and your velocity are both positive, you are speeding up. If they're both negative, you are speeding up. Because remember, a negative velocity simply means you're going in the opposite direction, correct? So if I have a position function, and my position function looks like this. Here's time. Notice I'm concave up. This is position. And let's say this is 2 miles. And let's say this is 1 minute. Okay. This is concave up, and it is increasing. Because it's concave up, velocity is positive. Because it's increasing, velocity is positive. Because it's concave up, acceleration is positive. If I have something like this, I'm starting to slow down, aren't I? And if you take a look at this, I am concave down, but my velocity, the slopes of my tangent lines are positive, aren't they? This is a positive slope right here. This is a positive slope right here. But that tangent line is starting to look like it might even horizontal out, right? So that means I'm concave down. That means acceleration is negative, but I'm still increasing velocity, so I have a change in signs. Now, if you reflect those over this axis, all this means my speed's exactly the same, I'm just going the opposite direction. But my function is decreasing, and I'm concave down. In other words, velocity is negative, acceleration is negative, but I'm still speeding up because speed is absolute value. Is that helpful? So when I come here and I'm on my calculator, I'm going to put 4 into v of t, and I'm going to have to figure out the derivative of this, which is my acceleration, and put 4 into that and look at the signs. And it says, is the particle speeding up or slowing down? I for sure would have, for my work, the value I computed for velocity and the value I computed for acceleration. So they know that I looked at the value, and then write down my answer. And if I have time, I would write down the reason why. Okay? Ethan, can I ask you a question that does not pertain to this problem?
Yes.
Okay. So I've enjoyed looking at your work. Okay. But, so are you handwriting it on a document?
For the AP classroom, yeah.
Okay. Is that what you're planning on doing for the test?
No.
Okay, good. That's what I think it would be. I know you, so I correct it because I know you. Okay. I don't think it's going to work as well for somebody that doesn't know you. That's all.
I just do that because it's quicker to put it into AP classroom. But yeah.
Okay. All right. That's fine. Okay. I just want to bring it up, and if I don't say it, I'm getting at the age, if I don't say it now, I'll go, oh, poop, like Wednesday, which is too late. Because if you look at my phone, it says now we are down to 6 days, 1 hour, 43 minutes, and 9 seconds. Ooh. Yeah, I hate these ads. I'm not a fan of them. It's almost worth paying, $1 billion so you don't have ads. I'm going to stop there, and we'll probably continue this problem and a little bit more as I go through your tests of stuff I want to talk about. Okay? Alrighty. Again, I really appreciate, hey, how do you do this type of questions as you come through. And looks like we got 20 people here, or 19 people here today, so that's pretty good. So if you see anybody, reach out to them, ask them how they're, that are in Cal class, how they're doing. And if you need to get in touch with me, you have any questions, feel free to do that. And I'm going to stop sharing, and I am going to get ready for BC Calc because they have a bunch of questions too. Okay, so we will see you all tomorrow.